Welcome to Hope Academy. My name is Mr. O, and today I'm going to be covering the SAT practice exam for the Math 2C, specifically numbers 29 to 32. And as usual, what I do is at first I do the question real quick, and then I go in depth as to how I was able to do the question so quickly. So I'm going to go ahead and get started on number 29. For number 29. Okay. Okay, for number 29, the final answer for this question is B. And now I'm going to go ahead and explain to you how I was able to do this question. So the question states that a line has a parametric equation and it gives you two equations, basically their parameters, and how do you find the slope. For this type of question, it's actually pretty easy. The only concept you actually need to know is the idea of parameters. And parameters is mostly a pre-calculus concept, but it's not too complicated. And the other thing you need to know is substitution. And substitution basically means that I could, in the idea that if I make one thing equal to another thing, and I make a random thing also equal to that another thing, then eventually you can make other things equal to each other. And I'll show you what I mean by that soon enough. So for 29, they tell you that the two equations are 5 plus t, and they also tell you that y equals to 7 plus t. And how it works is that substitution will come into play, because what's going to happen is that I'm going to get rid of t. T is the parameter that I'm working with, in which it's a substitute sort of variable that is in place of what's sort of needed at the moment. But that being stated, we want to get rid of t. So right now, currently I have these two I want to get rid of. That's my goal. And so what I'm going to do is that I'm actually going to do that. So I'm going to do is change this and move 5 over. So when I subtract 5 over, it'll be x minus 5 equals to t. And as mentioned before, these t variables that I have in front of you are very useful for us now. Now that I have t isolated like this, what I can do is that I could take this whole portion right here. I'm going to take this whole x minus 5 right here and eventually bring it into this t right here. Because now I could combine the two equations and make it into one equation. So that what's going to eventually lead up to, and I'm going to create the little arrow, is that I'm going to create this now. Y equals to 7 plus, now it's going to be x minus 5. And the part is that I paused at that point just because I have to remember what my end goal is. My end goal is not to simplify this equation, which I could, and I could end up writing this out, but this is not the necessary part of this work. The important thing is that you need to save time, and for me, automatically, I saw right before that this is what I need. This is going to tell me where my slope is, this x. And since x is by itself and there's no coefficient or front number in front of the x, automatically I know my slope is going to be 1, and thus how I got my final answer is B. And that concludes my explanation for number 29. And to continue on to number 30, what's the range of function defined by 1 over t? Okay, so number 30 is going to be D. And I'm going to explain to you how I was able to get to that answer so quick. So for number 30, it's actually pretty straightforward. The thing that saved me time on this question is the fact that I actually sort of have a visual understanding of how 1 over x will sort of look like. But that being stated, you could actually graph it onto a graphing calculator like the TI-89 that I usually have just sitting next to me. And you could actually sort of visually see it. So in case that you don't know it real quick, just go push the green button, Y for the TI-89. I'm going to erase the original equation there. I'm going to put 1 over x, and I'm going to graph it. And what's going to happen is that it's going to give you these two weird curvatures. If you notice right here, I'm going to sketch it right here too. So the basic idea is that it looks sort of like this. And the idea behind this 1 over x, y equals to 1 over x, and duly note, I didn't even put 1 plus 2 or anything. Just 1 over x equation looks sort of like this. And the part is that that's the standard image, how it's going to always look like. And you always got to remember one little rule about this, that there's always going to be an asymptotes right here. And I'm going to highlight literally the x and y coordinates, but there are always going to be asymptotes there and there. And then afterwards, the equation also, if you notice what they do afterwards, is that they include the plus 2. And so after I get that sort of, notice that sort of thing, the important thing you have to note is that when I'm doing this type of question, the concept that you really do need to know in order to know your range and whatever not is called a concept called transformations. And how transformations sort of work transformation. And how transformation sort of work is that it explains to you whether or not a graph sort of shifts left, right, up, or down. And because of this format that we were given, the original equation right here, y, or f of x equals to 1 over x plus 2, this is the important thing that changes the scenario that you're dealing with. This part right here is going to change your scenario, this plus 2. And what that plus 2 actually tells you is the fact that the original graph I have right here, will be shifted up 2. Shifted up 2. And why that's so important is the fact that literally what's going to happen is that I'm going to take this whole graph and shift it up 2. But what that also means is that this asymptote right here will stay the same because I can't really shift this up. It's going to be infinite anyways. But this line right here, this pink one right here, is going to also shift up 2. Thus why my final answer is D, where it states that all real numbers except 2 are part of my range. And I also want to review the fact that what range is, before I continue on. Range is going to represent as your y possible values, y coordinates, y values, whatever not. And so because your y is not existent at 0 beginning, it's now shifted up 2, that's what it represents. And so that concludes my explanation for number 30. Okay, and so to continue on to the next question for number 31. Okay, number 31. Give me one of this. Okay. Okay. Interesting. Okay. Okay. So. Okay. So. No. Let's do this. Okay. Oops, mistake here. Okay, let's fix that. Okay, it's gonna be 91. Okay. And then afterwards, this is the greatest number. I have more hours. January, February, March, April, May. April has 30 days. March has 21. 10 plus 41. Okay. So it's going to be that minus that. But I don't really care about those 35. Okay. It's going to be. Okay, got it. Oops, no, I don't want that. Okay, so for number 31, the answer for this question is A, and I'm going to explain that this type of question is not very common on the Math 2C. This one actually took a little longer than expected, and usually if you're given a question like this that's a bit longer and you know as a fact it's going to take a lot of time, I do highly advise that you actually skip that question, go to the next question, spend more time getting the other points, then come back to a question like this. The main reason why I say this is because this question actually takes a lot of time to solve it out. And it is something that it took a little longer than expected when I was doing this question, but that being stated, it's perfectly fine. I'm able to do this question, and now I'm going to be able to explain to you how I was able to do this. So the part is this. So originally when I read this question, it's the idea based on daylight savings. And so what happened was that I'm going to just explain it and break it down for you. But the idea is that the reason why I wrote down that sine 2 pi 3 over 365t equals to 1 is the fact that if you know a sine graph, an original sine graph or a general sine graph will always fluctuate as a wave. As you remember, in graphs, they'll always sort of have like this wave-like look and whatever not. And it always ranges between 1 and -1. That's the important thing you must always know. And so when you are working with this, you have to understand that the highest value, the sine value could be is 1. And so I solved for t in order to get that value. And the way you could do that, and I'm going to go ahead and do that, just in case you don't know how to do that, is the fact that when I make sine 2 pi over 365t equal to 1 like this, I could do multiple ways. One way is using the solve function on TI-89, but that being stated, for this question, it looks a little complicated to input, and so what I'm going to do is I'm going to do inverse sine. So I'm going to make 2 pi over 365t equal to the inverse sine of 1 and solve out that value. Afterwards, I can multiply both sides by 365 over 2 pi, 365 over 2 pi, and solve for t, which I got was something like 91.25. I rounded off a little bit, but that being stated, that's the value I got for t, and that represents the time. The t is the number of days after March, so 91.25 days. But that being stated, that's not what they're asking. If you notice, they ask for how many more daylight savings does March 21st have comparison to May 1st. And so what I needed to do afterwards, I actually did on the side right here, notice that I counted off the number of days after March 21st that exist, because I knew right off that between March 21st to March 31st, sort of, at the end of March basically, is 10 days. And I also knew that for the month of April afterwards, it's 30 days. So I took that, and then there's that 1 day for May. And so I ended up getting 41 days. Eventually what I did was I plugged 91.25, plugged into this equation, got that, plugged in 41 to here, and subtracted the two entities. And so I ended up just doing is I noticed that 35 over 3 is useless just because they will cancel out when I do the subtraction for the whole equations twice. And so I just basically did, and I will just write it down here, I did 73 sine 2 pi over 365, of times 91.25. And then minus 7 over 3 sine of your 2 pi over 365 times 41 days. I subtracted them and I ended up on the calculator getting something like 0.81. And thus why for number 31, my final answer is A. And thus why I stated before, this one sort of is a time killer question. I do suggest that you don't spend too much time on questions like this unless you could spare it at the very end. I do also want to mention that these type of questions are what I would consider like the level 4 or 5 type of questions, the hardest type of questions. And usually these type of questions usually come out the last 10 questions of your Math 2C exam. That's usually the case. And so just be aware of this when you're taking these exams like this. And now being stated, now that being stated, I do want to go ahead and continue on to number 32. So for number 32. Okay, so 99. Okay. XYZ. Okay. So that's not E. That doesn't make any sense. I know it's not B or D. That doesn't make sense. Okay. Okay, so my final answer for number 32 is C, and now I'm going to go ahead and explain to you how I was able to get to this answer. So the point is this. So the important thing is that I knew right off that when I was doing this question that my matrix will have to look something like this. This is exact the number set right here, but I knew that this was going to have to be laid out as like a flat sort of format where it's going to be 99, 199, 299. The reason why is that when we multiply matrices, and this is a concept also covered in pre-cal, a little bit in algebra 2 also. But the part is that when we're dealing with matrices and multiplying it, they have a very fickle sort of rule where, for example, usually you do want to set up the front values to be sort of in a row format like this, and then set it up like this, just because the multiplication will be a lot easier to sort of transfer out because it's rows times columns. That's how matrices work. And so for this type of question right here, I do want to keep track of that sort of format and make sure that I am doing it correctly along the way. And so what happens is that they tell you that this is 99, 199, 299 for X, Y, Z. So every time I'm using model X, I need to do 99. Model Y is going to be 199, and then Z is 299. And so how this matrix C actually works is that when I format it like this, particularly this way, it's going to be, I said, row times column each single time. So it's going to be, for example, if I just concentrate on this portion right here, the 99, sorry, no commas, 199, 299, and I take this, specifically this column 116, 19, what's going to happen is there's going to be 99 times 20 plus 199 times 16 plus 299 times 19. And so this will automatically give me the necessary pricing that I want to get, sort of like to eventually get to the total income. And then what happens is that this process will repeat again with the next column. So the next time you do this, it'll be 99, 199, 299, but it will be with 18, 5, 11, and I'll do the exact same thing again and again and again to get the total sum, which if you do it this format actually ensures that model X will be always 99 for all of these, 199 for this, and 299 for this, and thus why my final answer for this question is C. And that concludes my explanation for the Math 2C Practice Exam 1. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter, so that we can continue to make content like this. I hope you have a wonderful day.